Hello, and welcome everyone to the Fireside chat with Stephen Wolfram. I'm Ariman Patel, and I am the co-host and creator of University of Illinois' first and biggest campus talk show called the UIC Talk Show, for which we had the good fortune of talking with Dr. Wolfram just a couple months ago, as you can see. And joining me in this conversation today is China Yu.
Hello, everyone. I'm China from
Hello.
Hong Kong. Recently, I graduated from Johns Hopkins, and I'm now stepping into my journey as a learning design and technology master's student at Stanford. Today, our session on the future of AI and the era of AI will follow three major themes: envisioning the future of classrooms with AI, the role of AI and computation thinking in education, and discussing what educators should focus on teaching in this AI era. Before we delve into this exciting session, I would like to encourage all of you guys to ask questions using the Q&A button in the menu. We'll be addressing them as the discussion unfolds. Now, it's my pleasure to introduce our speaker for today's session, Stephen Wolfram. Stephen is the brains behind Mathematica, Wolfram Alpha, and Wolfram Language. He's also penned the revolutionary work, A New Kind of Science. As the founder and CEO of Wolfram Research, his contributions to the field are truly awe-inspiring. And we are thrilled to have Stephen with us here today to share his insights into the future impact of AI on education. Without further ado, let's dive in. Stephen, I'd like to start by asking, how do you envision the future of classrooms? What role will technology, particularly AI, play in this landscape? And can you give us a glimpse of what a day in the life of a student or a teacher might look like in this future?
Well, let's see. I mean, we've had all sorts of technology for a long time. I mean, it's been 35 years since Mathematica first came out. I think the thing to think about in terms of technology and its use is the technology that is being made available something that students will be able to sort of use for the rest of their lives? If yes, then figure out how to integrate it into how you're teaching students to do things. So, we've seen that process with kind of technical computing, mathematical computing, and so on with Mathematica and then Wolfram Alpha. We see that now, I think, with the sort of arrival of LLMs and so on. I mean, I would say that one question is, okay, what should you teach? What's worth teaching? All those kinds of things. I think that this whole idea of computational thinking, what is computational thinking? What's the point? The way I see it is, it's kind of a very important step in kind of how one formalizes one's thinking about everything. I mean, if you look back in the sort of ancient past, the big innovation of our species was figuring out natural language as a way to sort of talk about things in the world. You couldn't just hold up a rock. You could actually say, this is a rock. You had a word that described rocks. And then there were things like logic that got introduced a couple of thousand years ago that were sort of ways to formalize talking about things in the world so that you could kind of more clearly think about them. And then, the big thing that really came in the 1600s was kind of the idea of mathematics, mathematical equations, algebra, calculus, these kinds of things. And that was kind of another way to kind of formalize one's thinking and talking about the world. The way I see kind of computation, it's the next level of being able to formalize talking about the world. And it has this amazing extra feature, which is that once you have sort of formalized your thinking in computational terms, you can get a computer to help you do it. And so the way I see it, I mean, the thing I've spent the last, 40 years or so working on is trying to build kind of a computational language to express things in the world computationally. It's kind of you're back 500 years, you'll find, mathematics, people were just doing it with words. Then mathematical notation got invented, plus signs and equal signs, things like that. And then that sort of launched algebra and then calculus and kind of gave us modern mathematical science. What we've got now, and this is the kind of whole effort of Wolfram Language and so on, is to make a computational language that can express things about the world, whether it's talking about cities or animals or algorithms or whatever else. It's something where built into the language, and there's a very different kind of activity from sort of the coding, programming type languages. This is kind of a language that can sort of express things in the world directly, that directly knows about things in the world. And so the idea is that one can sort of crispen up one's thinking by expressing it in computational form, for example, with our computational language. And I think that's sort of a critical skill to be able to teach people, is how do you take things you might be thinking about and kind of cast them in computational form? How do you think about them computationally? once you can do that, a computer can kind of give you this amazing sort of superpower to kind of make use of the things that you have formulated computationally. So the way I see it is the most important thing to teach is kind of how to think about things computationally. It's not something people are teaching right now pretty much at all. It's a thing that, and it just got a lot easier to teach because the whole sort of mechanics of, write this computational language. Oh, I don't know how to do that. I only know how to write natural language. That barrier just got pretty much removed. I mean, back in 2009, when we introduced Wolfram Alpha, that barrier was kind of removed for this kind of one-shot calculational kinds of questions that you didn't have to know anything. There's no manual for Wolfram Alpha. People just walk up to Wolfram Alpha and start typing whatever they think about into it, and it's its job to kind of translate that internally into computational language and then be able to compute from it. But I think the big thing that's really important to teach is kind of how do you formulate thoughts kind of in computational form. That is now easier because one can sort of just say to an LLM in kind of natural language, hey, here's roughly what I want. Now, most of the time, what it will do is it will produce a piece of computational language which you can run, you can look at, and you'll say, well, that isn't exactly right. I didn't really mean that. The LLM interpreted what I said. I didn't do great expository writing and describing what I wanted to the LLM. And so the LLM produced something that is a nice, crisp representation of a thing that wasn't quite what I intended. So I have to do better expository writing. I have to maybe actually, understand this computational language to see what to do. So I mean, that this is one, to me, this is the sort of, we can talk about kind of what it means to teach people computational thinking and how to do that. And but that's sort of one step. You asked me, what do I see the future of classrooms? I think the other big thing that's a big piece of technology we're working on, for example, is kind of LLM-based tutoring, the ability to kind of have the analog of one-on-one tutoring with an LLM. And I don't know yet how well it will work. We're just doing experiments on this. I mean, I think our current sort of workflow, at least at the beginning, is it's kind of a teach to the test type of strategy, where the goal of the LLM, it says, I've got this curriculum, I've got this test that the students are supposed to be able to ace. Now, as an LLM, let me have a conversation, let me tutor the student, let me learn about the student, learn what it is I should be telling them at the right moment to get them so that sort of the thing the AI is trying to optimize is get the student to do as well as possible on the test. Now, I think the thing that gets very interesting very quickly is once you have information on, once you have this whole transaction, this whole discussion that's going on with students, you get to be able to do sort of assessment of whether the student understands things in a way that's much more interesting and more incremental than just wait until they do the test and see how many points out of 10 they get or whatever. And by the way, once one's seen a bunch of students go through that process, one's going to be able to know, oh, this kind of conversation with a student at this stage means that we can predict they'll do this or that well on the test at the end. So I kind of expect that what we'll see increasingly is more kind of incremental assessment, where the LLM is kind of figuring out, oh, I've seen students like this before. I can predict. I don't even need the student to do the test. I can predict what's going to happen. Another thing I think will happen is much more sort of individualized, both topic individualized and project-based kinds of learning, because it isn't the case when you have the LLM in the loop. It's perfectly realistic to have the student do this sort of personalized project about the thing they're interested in that also happens to teach computational thinking or math or whatever it is, and have that be something that the LLM can sort of patiently deal with. I mean, I think it's been interesting. We do this high school summer research program each summer. I've been doing it for more than a decade now. And it's always interesting. This is my moment of sort of extreme professoring, is figuring out projects for lots and lots of students there. And it's really cool to see students sort of enabled with this kind of computational language superpower. It's really remarkable what they can achieve in a very short period of time, and they can do something that is sort of original to them. Now, actually, this year, we tried using LLMs a bit in that process. And I would say that relative to our sort of human mentors and TAs, the the LLMs were definitely a step down, but we haven't really developed kind of, we're just in the very early stages of kind of developing the whole tutoring story for LLMs. And frankly, I think our summer research program is probably the most difficult case, because it's all custom projects. It's not kind of teaching to an existing curriculum and so on. But anyway, that was a long description of a few things that I think are perhaps pieces of the future. But to me, the thing all students really need is this: how to think about the world computationally, how to formulate questions you might ask in kind of precise computational form. That's a thing that it's a little bit of a different skill than what one is typically teaching in math. I mean, it goes way beyond the kind of, I've got a math word problem, let me sort of turn it into equations. It's and it's something where I think, the question of what do you need to teach computational thinking well. I know some answers to that. I don't think I know all the answers. Actually, it's one of my projects in the next year or so to try and create a kind of computational thinking course that that makes use of kind of modern LLM AI technology, as well as our computational language technology stack. And my current theory is, one of the things that's really important in teaching computational thinking is just knowing a bunch of facts about how computation interacts with the world. That is, how do you represent positions on the Earth? How do you represent things about time? How do you represent things about, I don't know, genomics? How do you represent, what kinds of things can you talk about? How do you represent something like color in a computational form? How do you represent images computationally, sounds, and so on? Each of these things is kind of, there's a certain amount of kind of facts about the way the world works that you need to learn, and then principles that will allow you to kind of formulate, if you want to think about, how do I sort of make this sound, remove the sound of traffic driving by. I'm not in my usual habitat, as you might guess here. But how do I remove the sound of traffic driving by? How do I think about computationally how I might do that? Well, you need to kind of know something about sort of things like how sound might be represented computationally and so on. I see there are lots of questions and comments here, but please. No,
yeah, so I mean,
something like CS50 is much more of a learn HTML kind of thing. What I'm talking about is to really think about, and what people have thought of as teaching coding is, I think, not what we want to go for. People have been trying to teach coding since the 1960s. What that's mostly been about is we've got computers that have a particular way they're set up with, variables and assignments and arrays and things like this. That's not how the world works. That's how people set up the innards, the low-level structure of computers. And the whole thing that we try to do with our computational language, for example, is you can say, what's the distance between two cities, for example. You just say, I don't know, geodistance of something that represents New York City, something that represents some other city. You're not dealing with the fact that underneath in the computer, there's all kinds of arrays and variables and APIs and all sorts of other things going on. That's kind of how the engine of the car works. That's not how to drive the car. And I think the thing that's really important for most people is sort of how to drive the car. And that's a thing that that's the sort of level that we're trying to talk about. Yes, my brother Conrad has written and said lots of stuff about this. It's probably a lot more sensible than what I have to say, but I mostly am a creator of tools to do these things, and Conrad has been somebody who's really thought quite hard about kind of how to plug what we think about into the actual structure of education as education is. I know, as you'll discover if you ask me questions about it, rather little about the structure of traditional education as it is. I mostly know about kind of mostly what I've spent my life doing is building tools to think about things computationally. And then I've gotten to do a certain amount of science using those tools. And it kind of gives me some idea of what's possible once you kind of understand things computationally. It's kind of, I was amused just yesterday to discover one of my young collaborators on our project to understand fundamental theory of physics. I hadn't really known this, but he first started using our technology and reading things I'd written about it back when he was in middle school. And so now we get another, whatever it is, decade and a half later, and that flower that seed has now bloomed, and now we get to understand lots about the fundamental theory of physics from that, which is nice. Okay, sorry, please.
So computational thinking, right? How would you apply it to more subjective fields? Like we talked about STEM, like we talked about coding, mathematics, physics, all of that. But if it's a subjective field, like let's say the arts or literature or something like that, how can someone computationally think if it's...
Right. So I mean, what do you want to ask about? If you want to ask about something like, I don't know, literature, let's say, okay, you got a book, you got a play, for example. Let's try and work out, what's the social network of characters in this play. Now, maybe you say that's not what the play is really about, but it would be kind of interesting to know that. It's kind of an interesting summary of the play. So it's rather easy to go and say, let's take the text of the play, let's find out, who's on stage at the same time. Let's make a graph that shows that network of kind of who's on stage at the same time. Kind of gives one some essence of what's going on in the play, perhaps. Perhaps we want to do something where we say, I don't know, if we take something about art, let's say we might say, oh, I don't know, we could just do this right now in Wolfram Language. You could say, take, notable artworks from Van Gogh. And, we got images of all those things. We know what the dates when they were produced. Let's try and figure out whether Van Gogh's sort of use of color systematically changed over the course of his life. And, how did that change? And that will be something rather easy to do. It's be just one line of computational language to sort of say, take the notable artworks of Van Gogh, find their dominant colors, for example, plot those in some plot of chromaticity plot of colors and so on. Those are a few things, but then, then you can start asking when it comes to artistic kinds of things. I don't know, you could start saying things like, let's try and work out, oh, I don't know, simple things like what color goes with what color and how do we start thinking about how that works. Let's take the example of let's say we want to work out, what color goes with what. Maybe we could take some sample of some huge number of images from the web. There's easy, we have such samples, and then say, well, what colors, given that we have the color green, what are the most common other colors that go with those colors? Those are a few kinds of things, but I mean, it depends on what you're going for. Another thing you might do is say, you're looking at a piece of text. You might try and parse it. So there's a function text structure in Wolfram Language, which gives you the parse tree, the sentence diagramming of each sentence. And so you could ask a question like an interesting thing to do with LLMs is to say, are they really boring in the way that they write text? Are all their sentences sort of diagrammed the same way or not? And how does that compare with a sentence that we might write as humans? Or I don't know, I can keep going. This is kind of an interesting free association process. I mean, another thing you might do, this is kind of a fun one. Let's say in Wolfram Language, you get word frequency data, just gives you for any word, it will give you the frequency of that word over the course of time based on a large corpus of text. And so it's kind of fun to see, if you're learning about some particular thing, you might say, how popular was the discussion, I don't know, well, even a word like war, for example, how much was the word war talked about? And you'll see these peaks. Then you can go in, if you're doing history, for example, you can go in, Wolfram Language knows, for example, lots of stuff about different wars and battles and so on. So you can make some geoplot or something of where were the battles in such and such a war as a function of time, and you can kind of get some sense of how it flowed and so on. I can keep going. I mean, this is fun. I think there's an infinite collection of these things. But
let's take that idea further. So let's say, do you see like these LLMs, right? We're talking about all these fields, and they're trained on a lot of data that already exists. Now, let's say you're working in physics, and do you ever see these models predicting something that we cannot see? Like, can we use these tools to show us some insights about the universe, or like it can be anything like art, physics, anything about.
Okay. Right. So I mean, LLMs, what they're fundamentally doing is trying to write text that is typical of text that is seen on the web. And that in and of itself is not particularly creative, so to speak. when you connect the LLMs to computational language, like with the plugin that we have with OpenAI or with ChatGPT, or the stuff that you can do with our new chat notebooks technology, then you get to have the LLM kind of formulate what one wants computationally, and then the computational language takes over and you can compute things that have never been computed before. Now, having said that, one of the things LLMs do is they're great at kind of finding average statistical facts from the world. So if you say, what was the favorite color in hats in the 1950s? Maybe somebody will have written that down, but quite possibly that's something you deduce in some aggregated statistical way from lots of things that were written about or in the 1950s or something like this. So that's kind of the statistics of knowledge is something that LLMs can deal with, which we're not, that's a good way to do that. Another thing that I think is true with LLMs is that just like they can do kind of SAT style, this is to that as that is to that, there are kind of correspondences between different areas, which I think LLMs may start to be able to do, that are things which, people like me who try and do fancy sort of basic science get very excited about, the analogy between theory of gravitation and metamathematics. Well, it could very well be that an LLM will be able to see that analogy as well, because it can see that kind of the structure of the way people are talking about general relativity is similar to the structure of the way people are talking about metamathematics. And then it can kind of say, aha, there's this analogy. I think those are the kinds of things that you'll see. I think in terms of being able to sort of discover new things, it's really connecting the LLM to computational language, because one of the things about computation is it's very easy to discover new things with computation. The challenge is often to understand what it is you've discovered. You can it's kind of like you run this experiment in the computational universe, you produce this amazing picture, could think of it as a piece of artwork, you could think of it as something that is just sort of out there in the computational universe. But now the question is, can we interpret that as something that we humans know about and care about, and so on?
Thank you so much. I think building on top of that, with LLMs, it's very exciting, and a lot of educators would love to bring it into their classrooms. And so would you mind sharing a little bit more about how you think these AI would be helpful in personalized learning, especially given the current state of LLMs, where there is a tendency sometimes to hallucinate and sometimes to mix facts together? And how do educators potentially balance between the power of these LLMs and the potential risk of these LLMs and services misguiding students?
Well, I mean, look, it helps to have kind of the computational language backend to the LLM. I mean, that's a grounding. If you have the right prompting, and if you use a chat notebook or you use the Wolfram plugin for ChatGPT, if we got the prompting right, and if the LLM is behaving itself, so to speak, then the chances are it will start asking the back-end computational language when it actually is trying to work out a piece of math or deal with facts. It doesn't always work. It's not perfect. I think that the way that, this is sort of an interesting challenge. And as I say, we've been working on kind of the LLM tutoring problem. And, I would say the jury is still out in terms of, can we constrain the LLM in such a way that it doesn't do things that we think are horrifying, but where it's still engaging enough that anybody cares about it? I mean, I think one of the things that people are discovering just in the last couple of months is that the more you constrain, the more you say, no, only do what I expect you to do, so to speak, the less the LLMs behave in an interesting human-like kind of way. But I think, my expectation is that the most relevant thing, LLMs are very patient, and they can also see in detail what students are doing. And so my expectation is that some of the most interesting stuff will be, a student is actually working on some project. They're trying to write an essay, they're trying to do some math problem, whatever else it is. And the LLM is watching what they're doing. And the LLM is gradually building up a model of how that student thinks. I mean, what I imagine for myself as well is that, I'll have a pet LLM that will know a lot about what I know. And so when it comes to, okay, explain to me something about how the institutional education works, the LLM will know, well, I already know about this or that thing. I grew up in England. I know this or that. Et cetera, et cetera, et cetera. So the LLM will say, well, the thing you really need to know is that in American schools, this or that happens. rather than just giving me the generic kind of lecture about, how this works, it will know what I know and know how to fit into what I should know next. And the same thing I think will be true when it comes to watching, typical students kind of try to figure something out. They'll get confused. The LLM will say, I've seen, say, here's the particular confusion you've run into. This is the thing to know, so to speak. Now, I think, there is a bunch of both tooling and some science, some just user experience and kind of, how the workflow is set up. That's important in making, we don't yet have the products we need to do LLM tutoring. We're going to try and build that. Other people are building it. We're working with lots of other groups that are trying to do this, providing, computational language kind of back end for that. It's something I think over the next, couple of years, one will probably see things that are reasonable. Now, having said that, the story of computer-based education is not a great story in the past. The story of things like, the tools, things like Mathematica, Wolfram Alpha, those have a place. The story, when I was a kid, embarrassingly long time ago, the books about the future always used to show these things that they called teaching machines, which were supposed to be things that would just sort of somehow magically teach anybody anything. That didn't happen. And nor did, the whole adaptive learning mechanisms and so on. I think with LLMs, there's a real chance this could actually work. I can't say that for sure yet, but I think it's looking very promising that that's something this time it will actually work. Let's see, there's a question here from Neil. I noticed that about prompt engineering. I do want to say one thing about prompt engineering. Prompt engineering is a great exercise in expository writing. If you were, in our company, for example, we've done lots of prompt engineering, and I would say that the most successful kind of prompt engineering tends to come from people who are really good at expository writing, and the LLM is very brutal in not understand what you're talking about if you don't do a good job in expository writing. I do want to say one other thing. It's about prompt engineering. Somebody's mentioning philosophy. I think now is the moment. In the past, there's been an increasing emphasis probably on specialization in education. Can you learn this big tall tower of tools, machinery for doing some particular thing? I think that the automation of a lot of that machinery makes it now much more important to learn kind of the generalists, to be a generalist, so to speak, to know about lots of different things. I also think there's a kind of very charming kind of correspondence between things like computational thinking and philosophy. It's basically, philosophy is a lot about, figuring out what questions to ask, figuring out how to think about thinking, so to speak. And that's kind of computational thinking is a way of kind of crispening up some of those issues, but the issues are very much the same. And I think computational thinking is in many ways a liberal art, more so than it is perhaps something that one should think of as kind of a STEM-derived kind of thing. It lets one do a lot of STEM kinds of things. For example, in my efforts to write about computational thinking, we'll see how it works, but I'm kind of imagining that once you've explained kind of the ideas of computational thinking, like explaining the core ideas of like calculus, for example, isn't very hard. I may be wrong, we'll see. I think I'm right about that. I've tested that out with lots of kids and things. Seems to work quite well. But it's something where if you start from kind of, if you're going up the stem of STEM, so to speak, it can be quite difficult. But once you have the ideas of computational thinking, it's rather easy to go to some of those things that have been traditional kind of STEM strongholds. Sorry, I was doing the wrong thing here. I was just looking at the chat to.
No worries, no worries. I guess for us here, with a lot of different educators being part of the group, do you have any kind of concrete suggestions for educators in terms of how they could potentially navigate this evolving landscape, whether that be incorporating how to incorporate AI into the classroom or teaching these computational thinking models? What kind of activities or discussions should they potentially bring into these kind of classrooms? Any suggestions on that?
Well, I wrote a book a few years ago called Elementary Introduction to Wolfram Language, which was actually intended, the target market for that book was high school students. Although it's turned out that book has also been read by lots of people older than high school students, but that's I would say that that is a sort of a no math approach to computational thinking that people seem to like quite a bit. So it's you can find it, it's free online. You can, it has, you can play with it and use it on the web somewhere. I mean, that's an example of a place to start that I think is pretty concrete. The thing that now the whole chat notebooks mechanism that we have, where you are dealing with one of our notebook systems and chatting with it to create Wolfram language, computational language code, and so on. This is pretty interesting and a thing worth, I would say, I know a lot of educators are playing with this. I don't think we quite yet know exactly how to fit it into the workflow of classrooms. Hopefully we will know that within not too long, but this, you know, the whole chat notebook mechanism is like only weeks old. So it's kind of, this is sort of breaking news, so to speak. I think it's, let's see, I mean, I think, let's see, I'm seeing various other, let's see, there's a,
as someone who writes a lot, like you, I'm talking about you. So would you ever use these LLMs to derive pieces of writing, or would you consider them original, or would you never use them?
Well, I mean, I write pretty quickly, so it's a frankly, it's easier for, I don't know how to formulate my thoughts in a way that an LLM could help me very much with. I'll tell you some ways that I use LLMs today. For example, we have a daily digest of new papers that have been produced in the world about LLMs. And so some human has picked out, I don't know, 25 of them each day, sends out within our company. I, you know, was looking at the abstracts of these papers, and it's like, I can't read these things. Everyone is written differently. They, you know, they get 5 sentences before they actually say anything. I just wanted an LLM to give me a 2-sentence summary of every paper. That works really well. The summaries are kind of, they're rather bland in terms of English writing, but that's great because I can then read, you know, I can scan through 25 of them very quickly. That's a very good use case. I would say that other, you know, there are a lot of strange use cases, well, for me in terms of sort of the creative side of LLMs. One of the really fun ones is, you know, LLMs hallucinate stuff, and they hallucinate Wolfram language, just like they hallucinate text. And one of the things that we just recently started to do is they hallucinate names of functions that don't exist. But actually some of their ideas for what should exist are surprisingly good. And actually we just probably within the last couple of weeks made the decision to actually implement some functions that LLMs had hallucinated should exist. And you know, now we're actually going to, you know, make the hallucination into reality, so to speak. So that's another kind of case. I would say that the thing I've noticed is when I've sort of, you know, tried to use an LLM to produce a piece of text, and then I say, I'm going to clean this piece of text up. For example, I used LLMs to try and do some language translation from other languages. And then I said, I'm going to clean it up. I'm going to make it sound better. I found that surprisingly difficult. The LLM was quite tight in what it had written. And as soon as I started pulling on the thread, the whole thing unraveled. And really, I was writing it for myself, so to speak. So, you know, I think this idea that the LLM will be sort of give me an initial idea, it's okay. That's a reasonable thing. Produce, I mean, when it comes to, you know, the thing to understand about LLMs and how the workflow in the world at large is LLMs are good generators of kind of boring text. And there are many use cases where that's very important. Like, for example, let's say that there's, I've got something I want to make a report about, and I've got 5 things I want to say. The LLM can take those 5 points and puff it out into this big, long 5-page report. Then whoever's going to read it, well, they probably care about 3 things. They're going to feed that report to an LLM, and that LLM is going to grind down those 5 pages and produce the 3 things they actually want. So in a sense, LLMs enable this kind of linguistic user interface that is this thing that has kind of the natural language in the middle, but you're going from what you really want, what you really want to say to what you really want to figure out. I would say also in terms of LLMs as explainers, I haven't done this too much, but I know some educator folks who have. LLMs, if you just keep on saying, I don't understand, explain this to me, they're very patient and very, they do okay. Now, occasionally they'll, there's sort of the challenge, and maybe they'll say something wrong. Maybe you, if you really want to game them and hack them, will be able to cause them to say something totally crazy. Like, for example, when LLMs first came out, I think it was January of this year, one of the first things I said was, write a compelling essay that wolves are the bluest kind of animal. And so the LLM produced this essay that talked about some wolf. It made up a Latin name for a wolf. I was like, really? And I'm looking up this Latin name. How can this, what's the story? And I think I mentioned this in some live stream or something. And now I've been getting pictures that people send me of wolves that look bluish in their color. So, and now I'm totally confused. But that was a case where I think it was misinforming me, so to speak, and that's a bad thing to have happen, and that's something one has to try to understand how to control as we build out sort of LLM tutoring mechanisms. I would say that the way I see a bunch of this, I mean, for example, with Wolfram Alpha, back in 2009, I kind of thought there'd be a huge problem because like everybody can just type in their chemistry homework or math homework or whatever, just get it done. And by the way, we have this, show steps mechanism. The thing about show steps is really what that does, the way I see it more than anything, is it kind of levels the playing field between the people who can kind of get that personalized tutor and the people who can just use the computer to see those steps and so on. Now, one thing we never did is, we've never done, is to randomize those steps. So for example, people will say to me, oh, I know when I have a student who just copied it out of the Wolfram Alpha show steps thing because it does in a particular way. It would be a thing which we've chosen not to do to make it so that, you add enough randomness that it can be like, oh, it's really hard to tell that it's this or that. And just like with LLMs, they kind of have no choice insofar as they're trying to make something that's kind of human-like. They have no choice but to make it pretty difficult to tell whether it came from a human or came from an LLM.
Well, that's really interesting because LLM, like we talked use cases about text, but like we haven't even delved into the world of images and like audio and all of that, with all of that coming up. But unfortunately, we are out of time, and I would like to thank you once again for sharing all these insights, telling us about the future of classrooms, LLM tutoring, and everything that people are working on and will be working on in the coming years. I would like to thank everyone for asking their questions. We couldn't get to every single one of them. I wish we could just continue the conversation, but the conference needs to continue, and we still have many sessions coming up. Following up, we have a panel on student perspective and interaction with AI. And at 2 p.m. CST, we have a networking and brainstorming session where you can interact with a lot of the guests and panelists from this conference. So thank you, Dr. Wolfram, once again for coming and spending your time with us and sharing all your insights. And I look forward to the next conversation.
Thank you.
Thank you so much. Have a good one. Goodbye.
Bye.